Hello, everyone. Welcome to another lecture for Auto 105 Manual Drivelines. Today, we're going to talk about Chapter 4. Now, Chapter 4 goes in primarily into bearings, but we'll also look at the seals and gaskets that can seal the case off on the transmission transfer diff, and then also finish up with lubricants. Bearings are one of the most important component when we look at all of the driveline systems. When we're looking at the manual, even the clutch system to begin with, and then the manual transmission, transfer case that has one, driveline, and then down to the differential. One of the things you hear a lot of people talk about is, what's the horsepower between crankshaft and what's the horsepower when it goes to the wheels. And often, when people are trying to flex, they'll give you the horsepower at the flywheel or the crankshaft. And the reason for that is it's higher, it's a bigger number. On average, a vehicle's losing about 15 to 30% in driveline losses. And the main form of that driveline loss is in friction, heat. So if we don't have, low friction bearings that reduce the amount of strain that everything's spinning at, we then lose a fair amount of our horsepower that the engine is producing. So these are extremely important. And there's a bunch of different bearings, again, starting at the clutch, going all the way down to the drive wheels, that serve different functions and have different slight designs. But the main thing that we're looking at is it's a multi-piece component that will allow for smooth rotation or smooth operation of a component. When we look at like a throwout bearing, for instance, a throwout bearing usually is a roller bearing or a ball bearing, and it does rotate, but it's rotating because the crankshaft's rotating, and it is actually applying and putting force onto the pressure plate springs to release them so the clutch can release. So when we look at like a throwout bearing, it's a very dynamic bearing, and then it's spinning plus being forced against the pressure plate springs and having to overcome those forces. So there's a lot going on when we look at individual bearings. We have a wide variety of different types of bearings, and each bearing will have its own specific unique design that makes it beneficial for that particular job. When we look at wheel bearings versus bearings in between shafts of a transmission, they're going to have different design characteristics that they have to be under. And so we'll use one bearing in one task, but not in another. So they're not going to be all the same. Obviously, too, keeping these bearings lubricated and cooled and maintained is going to be another big key characteristic. To go back to that throwout bearing we were just talking about, there's very little maintenance you can do to a throwout bearing. Early vehicles, they'd have an access cover that you could, put a little bit of grease. It had a Zerk fitting, and you could grease the throwout bearing. But modern vehicles, it's sealed in there, and it's sealed for life. And when we're looking at the life expectancy of a vehicle being anywhere between 150 and 500,000 miles, that bearing's going to live a pretty hard life and have to live it with a very mere ration of grease. And it's understandable if they fail over an amount of time. Different types of bearings that we're going to have is they kind of fall under two main camps in terms of design, and then they can, have a varying from that point. But we're either going to have a serviceable bearing meaning that we can service it, we can take apart the outer or the inner race and get access to the rollers, the balls, or the needles, and it can be repacked with new grease. So you can pack new grease in, you can clean them, you can adjust them for preload and tension, and they are otherwise disassemblable. The second main category is a sealed bearing, and we're seeing more vehicles come with sealed bearings, and this is a bearing that is sealed up and not meant to take apart. Often people will look at it as like, oh yeah, it's sealed from the factory, and yeah, so it's the bearing is constructed, your inner race, your roller, the caging system, grease or oil is put in it, and then you have the outer race, and the outer race has metal seals kind of keeping everything together so that once these bearings go bad, they go bad. You can't rebuild them, you can't repack them, you can't adjust them. They are what they are. Now that being said, there's a lot of people that will do the like, oh, they don't make it the way they used to. You used to be able to rebuild bearings. Well, the reality is cars wheel bearings now, even for like the smallest, Hyundai Accent or Honda Civic, is much larger than if you had a Cadillac Fleetwood, their front bearings. So they're much larger, much more robust, and under and able to withstand much more strain and pressure. So as having a sealed bearing isn't that big of a deal. Now, whether that being sealed or not or serviceable, we can have a bunch of different designs in terms of what type of bearing it is: cylindrical bearing, tapered roller bearing, ball bearing, double ball bearing, double tapered roller bearing, Torrington bearing, and then you can have solid bearings, bushings, and somewhat. So there's a bunch of different options that are out there, and each manufacturer will look at the different design characteristics for each one. So very simple bearing that a manufacturer might have, and you'll see these a lot on manual transmissions, is going to be a single row cylindrical roller bearing. And this has rollers that will go around an inner and an outer race and are caged. They can be sealed or they can be non-sealed. And these are bearings that are going to be used when there's no side loads applied to them. So they're just going to be supporting a shaft. That's why we tend to see them on manual transmissions. When we take apart manual transmissions, you'll see this as the front bearing for the input shaft. You can see it as the pocket bearing, which is the most important bearing inside of the transmission. And you can also see it as supporting the output shaft and the counter shaft. They don't like a lot of side load, which transmission isn't going to get any side load. It's just reducing the friction and supporting the shafts. But where you won't see these is you won't see these as like front wheel bearings. You will see these on rear wheel bearings, but a lot of manufacturers tend to do the other design of a tapered roller bearing instead because they can handle more torsional load. Now, these cylindrical bearings, what they tend to have is they tend to either have just an inner race or they more often than not have an outer race, and then the cylinders are locked in place. The inner race is usually going to be the shaft of the transmission or transfer case or whatever it happens to be. When this is the case, that is a wearable surface. So the bearing that I have photoed here is a straight roller bearing. We have our outer race and we have the rollers in place. And we'll say, just for argument's sake, that this is going on an input shaft of a transmission. So the input shaft of the transmission where this bearing is rolling on would be the inner race surface and thus fall under an area that we need to inspect if the bearing does go south and get damaged. Now, the next design, I already kind of brought it up, which you see a lot more often because it can handle side loads, is going to be a tapered roller bearing. So under the same kind of guise and design as our roller bearing is that we're going to have, kind of cylindrical cones, cylindrical bodies going around an inner and outer race. But the difference is they're at an angle. So our inner and outer race will be at a particular angle, and this angle is going to vary depending on how much side load or thrust that bearing can support. The greater the side load, usually the more thrust it can handle, but the more preload and strain the bearing will be. Usually you're looking at anywhere between a 20 to 30 degree. I have seen 40-degree tapered bearings. They do exist, but again, it's dependent on the manufacturer. These bearings operate under very light, load and friction, but they do require preload or an amount of pressure put on the inner and outer race against the rollers so as to not have them fail. This preload is adjusted in a couple different ways on transmissions. It can be adjusted by selectable shims, like what we have photoed right there. We have our outer race, so I'll draw this out for you so we can see a little bit more. We have our outer race right here. This would probably have an interference fit against the housing of a transmission or a differential. We have our inner race, which is this structure right here, with our cage and rollers on the outside of that. And then our shim that is going to provide our preload. Now, you can have it either as a shim or you can have it as a threaded collar. But what preload is putting a set amount of load or tension on that bearing to allow for it to have full contact against both races. Why we have to do this is if we don't have the preload, the bearing will chatter on itself and it'll fail prematurely, usually pretty quickly. So it is very key that we make sure that anytime we are replacing a tapered bearing, that we always make sure we're double checking our preload. And our preload can be done usually with a turning torque or a breakaway torque wrench to measure how much it takes to start to rotate that bearing. Now, tapered roller bearings can be in a bunch of different applications. They can be in the supporting role of the different shafts inside of the transmission case. You'll find them in transfer cases. You will definitely find them in differentials. These will be the side bearings, the pinion bearings, and oftentimes the wheel bearings in the rear. We can also have these in a double row configuration, which we'll talk about here in a little bit, a greater detail, to support an axle shaft or more often a wheel bearing. And because the tapers are going opposite of themselves, they're going to be able to hold or be able to withstand, I should say, a lot more thrust load being applied to them. We can also have ball bearings. Now, ball bearings operate off of a much lower friction rating than the other ones, meaning that they are more efficient. Downside is, though, to where our straight roller and our tapered roller, their benefit is they have really big surface area, so they can handle a lot greater loads. Ball bearings to handle greater loads, we either have to increase the diameter of the ball bearing itself, which then increases the overall bearing, or we have to run them in multi-row configurations. Now, our ball bearings will have kind of unique inner and outer races that will allow for the full support of the roller ball itself. And that will control our side load. So we don't have as much chatter as we would with a regular roller bearing. And again, we can have these in multiple different configurations in terms of double row or single row configurations. Usually, we're going to see double row configurations as wheel bearings, and for that, that increases that surface area that we were talking about as its kind of weak link. But when you combine them as a double row bearing, they do support a lot of side load plus a lot of regular weight. More often than not, when we do have them as a double row, the inner race will be two pieces. So you'll have a top or a bottom or a left or a right inner race, and then the outer race will be one piece. Then that's because the outer race is usually going into the fixture of the steering knuckle and or the transmission case to support everything. Inside of our transmission and inside of our transfer cases, where we'll see something called a Torrington bearing. Now, a Torrington bearing is a very small, flat, thin roller bearing, but the difference is where a straight roller bearing or a tapered roller bearing, the rollers are very close together. In a tapered roller bearing, they will have some separation with the bearing cage, but in a straight roller bearing, the rollers are rolling against themselves as well as the inner and the outer race. A Torrington bearing is going to have separation. Now, a Torrington bearing is going to be able to control thrust movement inside of a transmission or transfer case. So that movement in or out. You will see a lot of these in place for low friction applications. They can also be, replaced with a bronze bushing. However, that does build up the friction and make that transmission less efficient. Now, friction bearings or bushings, these again are solid or single piece bearings or bushings. They're not going to have any rollers. More often than not, inside of a transmission, we will see these supporting shafts on early transmissions that they don't need the efficiency. But primarily, where you will see these on modern vehicles is going to be our pilot bearing. The pilot bearing is what's going to support the end of the input shaft so that the clutch can operate, and will be typically located in the back of the crankshaft or the flywheel. These can be made of a bunch of different materials, but usually they're going to be made of a material that is softer than the shaft it's supporting. So if our input shaft is made of steel, we can have these made of bronze or brass that is a softer material. In some cases, you can have some lubrication on these bushings, but for the most part, these are going to be dry bushings, and so therefore the softer metal acts as its own lubricant. Now, all of the different types of bearings that we talked about there in the last couple of slides, all of them can be a sealed design. Now, a sealed design is, as I brought up at the beginning of the lecture, a bearing that the inner and outer race are stuck together mechanically, and they will have a metal seal, and all of the grease and lubricant is pre-filled into that bearing and not needed to be changed ever. Now, the running clearances on these will also be already set, so any preload that's in there, because you can have a tapered bearing or a double taper roller bearing that will have the set amount of preload and lubrication already installed. A lot of modern wheel bearings are set this way, and we can have this kind of be supportive of we'll have a wheel bearing hub assembly and the wheel face hub with new studs, as well as usually a pickup point for the ABS sensor or wheel speed sensor. Now, that can be used off of a magnetic pickup wheel, or we can actually have a demagnetized part of our wheel bearing race itself act as the tone wheel for that speed sensor for the use in the ABS and use with traction control. When we look at serviceable wheel bearings indicate that we can take the bearing apart. However, we still need the grease and lubricant to stay around the bearing rollers. So what we'll have is we'll have to have a serviceable seal or gasket. Now, these gaskets or seals typically are going to be considered a dynamic seal, and you will see a test question about that. And what a dynamic seal indicates is that it will statically be in place, but it will be sealing something that dynamically is moving, so a spinning shaft or a moving rod or anything along those lines. Now, these seals have to be able to provide dirt and debris from not getting in, but also to allow for the lubricant to stay in place. And so they kind of have a really, really tough job. One of the ways that can make that job a little bit easier is on these lip seals, we will have what's called a garter spring. Now, the garter spring is going to put tension on the lip seal. The lip seal will actually come to a point and ride across the shaft or sealing surface. And that spring is going to provide constant tension. What that means is that means that dirt and debris can't get in, and that means that grease and oil can't get out because of that constant tension. And the lip design will have a specific direction that it goes. So that the oil that it might be trying to get forced out through centrifugal force will actually in turn get turned back around and sent back through the into the case via some fins, and the dirt and debris won't be able to get in through the other usually reinforced dust shield portion of the seal. Now, one interesting thing that you will have happen with garter spring seals is because that garter spring is putting constant tension on that sealing lip, over time, you can wear a groove in the sealing surface. And it's kind of funny because you'll have a rubber seal that can wear a groove in a steel component. And quite often, what can happen is that sealing surface needs to have either a sleeve put over it or it be remachined, and a undersized or oversized seal be installed due to that machining process. Now, to allow for these dynamic seals to operate correctly, they will have an interference fit against the housing that they're riding in. So if it's supporting a steering knuckle or a spindle or a shaft, that will be spinning dynamically independently of the hub it's on, but the seal will need to be fixed into that. So there will be a slight interference fit, meaning that the outside diameter of our seal will have a greater dimension than our inside diameter of the hub that it is being applied to. So it's really important to make sure we use the correct tool when installing these seals as to not damage them or punch them all the way through or get them to be crooked. That's a fault I have quite a bit is if you don't have the right tool and you try to very lightly tap in the seal itself, I tend to get them crooked. For whatever reason, I have a hard time with that. So it's always good practice to find the correct tool as to not cause any additional damage or wreck your brand new seal before it's even been used. We can also have just regular O-rings. Now, these would be considered non-dynamic. So in the case here, we have a output shaft or a speed sensor on a transmission case, and it has an O-ring located on the body of the sensor itself. And this is non-dynamic. So the speed sensor is not moving, neither is the case. It will just be kind of a static seal preventing dirt and debris from getting in and fluid from getting in, but it's not going to cause an issue where we're wearing a groove on the case or on the speed sensor itself. Now, these sensors, or these seals, I should say, they do come flat over time. So, where you have an issue in terms of wear or why they might leak is either rapid expansion and contraction during different thermal events of that component that can cause the seal to go flat over time, and then fluid and dirt and debris can get around that, and the seal then is otherwise not usable anymore. We can have a variety of different gaskets too. Oftentimes, when we're looking at transfer cases and transmissions, we won't have any gaskets. Most manufacturers go to where they have such a fine machine surface that we'll be using usually an anaerobic style sealer or gasket maker. And anaerobic means lack of oxygen. So we have such a fine machine surface that we can have this anaerobic sealer seal up, and because there's a lack of oxygen, it will harden up and prevent, again, fluid from leaking out and dirt and debris from getting in. But we can have rubberized seals with metal membranes inside of it to add some rigidity. We can have straight rubber or cork style gaskets. Now, these gaskets do require a small amount of fluid to expand out so that they can swell and operate in a manner that they take up all of the different little variations. And then we can have different paper gaskets. And the paper gaskets, again, this will be a special fibrous paper that will allow for it to expand out and seal everything. I brought up that some of the cases will use an anaerobic sealer. An anaerobic sealer is going to be a gasket maker. Another common one is RTV. RTV standing for room temperature vulcanization. What that means is that under ambient normal temperatures, the liquid sealer will come out of the container and turn hard and harden based off of just the normal room temperature. Oddly enough, some of this RTV does require a set amount of humidity in the air for it to fully harden. And so that you will see some mechanics, they'll have a little spritzer bottle, especially in the dry areas of the Southwest here, that they'll spray and they'll spritz the RTV to try to encourage it to harden up and seal. Now, RTV is preferred by manufacturers now because it takes and fills the machining imperfections, as well as it's really cheap. You can have a tube of sealer be the one size fits all sealer, so the manufacturer doesn't have to design gaskets for each individual case half. It is important, though, to make sure that we get the right sealer for the right job. If you go to the parts store, there's going to be a multitude of different sealers that you can choose from as a mechanic. But it's going to be really important that we make sure that we get the right one based off of the material that we're using and based off of the fluid that it is trying to seal against. Also, too, the other thing that comes into consideration is temperature, how much it's expand and contract are also two big key characteristics to make sure that we get the right sealer for the right application. Too much is an issue on these as well. So on the photo here on the right of the screen, we can see we have a fair amount of material that has kind of pushed itself in because the mechanic used too much. So usually we'll see a ribbon of material on the outside. That also means that there's a ribbon of material on the inside. This isn't so much of an issue on a manual transmission since there's no pump or anything, and it just can, get ground up in the gear set. Where it is an issue is on transfer cases. Almost all modern transfer cases will have a pump and a pickup, and that pump is used for our locking clutch for 4 low versus 4 high. Now, if we have too much silicone sprayed or RTV, splayed into the case of that transfer case, that can cause it to plug the pickup and otherwise cause a lack of lubrication in that clutch to then burn up and prematurely damage our transfer case. So it is really important we use the right amount. And you follow service information for not only the correct RTV silicone, but also for the right amount that you would want to apply. Where we'll also see some sealer that's going to be needed is going to be on the threads of the case for the transmission and transfer case itself. I've also seen thread sealant needed on the pinion nut of the pinion shaft of the differential. But we tend to use liquid Teflon sealer. Don't use tape. Honestly, it's not a good idea to use tape in any automotive application. Use the liquid Teflon. It gets into sealing the imperfections of the case at a greater rate, and we don't run the risk of the tape burning and or the tape collapsing or going into a bore. So use the liquid Teflon when you can. Removing these gaskets is going to be really important. The machine surface of our transmission cases, transfer cases, and differential cases are going to be very finely machined, and they also almost always, with the exception of the differentials, are going to be made of aluminum. So we need to use a non-marring way to remove the material. At the bottom of the screen there, the red uh, plastic scraper is kind of my scraper of choice. They're really thick and robust, and they're really strong Delrin, and they hold a sharp edge very nicely. You can also go through and resharpen them, but you can get a brass or copper gasket remover as well. There's also you can use the aerosol gasket remover. Now, that stuff though, however, yeah, it can get a little bit rowdy, and can have an issue where it's not good to breathe in, and it can take off an anodized coating that might be on some of the material. But we do want to make sure that we are not, causing any warps or damage based off removing these gaskets. A good check to do after the gaskets are removed is to go through with a feeler gauge and check for case warpness. What we're looking for with that is we're holding a straight edge across and we're using a feeler gauge. You tend to not want to be over 2 thousandths of an inch. 2 thousandths of an inch is usually the general. That is the amount that we can't go over for our case warpage or our difference in our surface for a case. We're also looking too for any types of over torque or damage to case structures. This is especially the case if we have a transmission case that's aluminum and we have a metal pan that's bolted to it. More often than not, they can very easily get over torqued, and we can see that with the photo on the right there, where that bolt has started to groove and eat into that pan or that cover. I often, to correct some of these issues on steel pans, I have a body hammer that I use, and oftentimes a couple, light taps with the hammer will straighten it out. A ball peen hammer will do the same thing. The reason why I like a body hammer is you can get body hammers as either a shrinking or a stretching hammer, or you can get them as a neutral one. A ball peen, depending on how you hit it, will shrink or stretch the material. So ideally, you want to try to maintain it as flat as possible. So you don't want to hit on it on the side or anything on the ball peen. You hit it nice and flat and straight with a regular hammer. If we have a gasket, or if we don't have a gasket, but we have multiple bolts on the flange of whatever device we're torquing, if whether or not it be a transmission case, a T case, differential cover, or adapter housing, we want to make sure that we're using the proper torque sequence. When we have a gasket, the gasket has to be collapsed down in a manner to where the forces evenly distribute on it. So we try to go in a cross pattern to allow for that gasket or that sealer to flatten down nice and even and not have one side up over the other, because that can cause a leak, as well as it will damage the threads and potentially cause a crack in the main housing of the unit. So following the proper torque specification and then also following the sequence is really important. Even if you don't know the sequence, if you go in a cross pattern, going across to the next side and then doing that in a spiral, you're usually going to be able to torque it nice and even without any dramas. Now, lubrication is going to be the main thing that we are trying to keep in with these seals. Having the right lubrication is going to be very paramount. Each transmission will use different lubrication based off of a couple key factors. For a manual transmission, we're almost always going to have a determining factor being what the synchronizer construction is. Now, the synchronizers can either be solid brass or bronze, and in that case, we can use gear oil. Usually, though, we're using a lighter gear oil. In fact, in some cases, on some Mercedes transmissions that have serviced that have been in Chrysler vehicles, you're using engine oil. You're using 530 or 540 engine oil. You're not using anything heavier than that, because heavier materials would then, not allow for smooth and frictionless operations. If the friction lining material on the synchronizer is paper, then we will be using ATF or automatic transmission fluid instead of gear oil. And the reason for that is that friction lining is going to be very similar to that of what we're going to have in an automatic transmission. It's going to be a paper-based friction liner, and that will then require the use of automatic transmission fluid because it can withstand the different temperatures increasing and decreasing for that paper, as well as uh, prevent it from shrinking, and it will allow it to be swollen in the right dimension. Always refer to service information anytime we're looking at the servicing the transmission and or differential. When we look at differential, for instance, it might take a multi-grade weight or it might take a single weight, and the service info will give us that information. A main thing to look at for a differential, though, is whether or not it has a limited slip set of clutches to where we need to put a friction modifier in the fluid. The friction modifier is going to allow for conditioning of those clutch discs so that they don't slip. If we don't have the friction modifier in it, we're going to cause the clutch disc to chatter and ultimately fail prematurely. Checking the level on a lot of these systems is pretty simple. Almost all of them will have a fill and a drain plug. Automatic transmissions, often we have to, remove the pan to drain the fluid. But in manual transmissions, we're almost always going to have a drain plug with a corresponding fill plug. Same thing with a lot of differentials. However, if it is a iron differential, oftentimes we do have to remove the cover to be able to drain the fluid. But these drain and fill ports are put for easy maintenance. I always, anytime I'm doing service on a case that has a drain and a fill plug, you remove the fill plug first for a couple reasons. The first reason is you'll be able to check the existing level. Oftentimes the level or the fill point for our transmission cases is, or differential cases for that matter too, is going to be right at the bottom of the threads of the fill plug. So if I run this line across this back pitched photo of a differential, that would be where it is. However, per service info, it might be a little bit lower. So that way you can see, what the level is before you start. You especially want to do this if you know that the system has no leaks. So if the system has leaks, you're checking to see how much fluid is leaked out because potentially that can be, where you might want to start to get into inspecting for damage. But in the case of, there's no known leaks and we know that the system's been sealed from the factory or by reputable mechanics, we want to check the level because the level might be slightly lower, and filling it too high would cause the fluid to cavitate, can cause bearing failure, and can cause the fluid to be pushed out of the seals, typically the vent or the pinion seal if it's a differential. Now, the viscosity rating, that is going to be its impedance to flow. Oftentimes, we're going to have multi-viscosity oils inside of our transmissions and differentials. Our transfer cases tend to either, if they are using gear oil, it'll be a single weight gear oil. More often than not, they're using a specific automatic transmission blend. A lot of times, they're using their own specific, like this is what we use, and it's only used in transfer cases. But our multi-viscosity oils will have a viscosity that will change based off of temperature. The W is going to indicate a cold weather or 0 degrees resistance to flow. And then the second number that doesn't have the W will be the resistance to flow at operating temperature. We're going to have much thicker viscosities for gear lube than we otherwise would in an engine or anything else. Up to 75 140 as some of the options. Now, based off of that thicker viscosity, that can obviously really affect the efficiency on how that transmission or differential is going to operate. So it's very important to make sure we're referring to service info to get the right weight oil and thus not have it decrease our efficiency. These oils will meet different ratings too. They will meet an Automotive Petroleum Institute or API rating. We're looking at modern oils being GL5 and GL6. The book is a little bit out of date here with calling for GL4. Now, the nice thing with that, though, is if you have an older vehicle that does call for GL4 rating oil, the new oils are backwards compatible, meaning if you have a GL6, it goes backwards towards that GL4 and can be used. Now, in terms of wheel bearings are going to have usually high temp grease, and grease is going to be much thicker than our gear oils and require a specific temperature rating. Almost always, you're going to have high temp grease for wheel bearings if they're a serviceable wheel bearing. Now, based off of that, though, we do want to make sure that we're still looking for the proper service information, that we're not using a grease that's not applicable. Oftentimes, these greases can have molybdenum in them, and that's kind of a darker material. Can often be called, and it's in a shorthand term of moly. These moly lubes are going to allow for low friction use, but allow for the material to be able to withstand higher loads. Now, as I brought up before, oftentimes some manual transmissions will use automatic transmission fluid. One key characteristic for that is again going to be the construction of those synchronizers. Now, if this is the case, oftentimes transmission manufacturers will put a sticker on it. So, as what we have photoed there on the right for our T56 transmission, which is a 6-speed transmission made by Borg Warner and Teramec. These transmissions will use automatic transmission fluid. And again, just like the GLI ratings for gear oils, in this case, this is calling for Dextron 3. If we have Dextron 6 or 7, which is what is out on the market now, it is backwards compatible and will work. There's also two, GM has a synchro mesh transmission fluid. That synchro mesh transmission fluid is a special transmission fluid that is a little bit thicker version of automatic transmission fluid. So it is safe and compatible with paper synchronizer rings, but adds a little bit more stability and stays a little bit more resistant to flow and cling on to components when used in a transmission. It's also Pepto-Bismol pink, which is a little bit weird. Automatic transmission fluid is kind of, a cherry limeade or, cherry kind of color. But you can still see that it's see-through to where oftentimes the synchro mesh can be look like solid pink Pepto-Bismol. Now, diagnosing bearings for noise is going to be the number one thing that you're going to see for why your bearing possibly has failed. They will tell you, they'll talk to you to let you know that, hey, I'm not happy. More often than not, you're going to see bearings that you will be diagnosing as a bearing that has failed as wheel bearings. Wheel bearings tend to not live as long a life, and that's usually because of the driver hitting large potholes or curbs or being overloaded. Over time, though, these wheel bearings can just wear out over time as well and require a replacement. Checking for loose wheel bearings you can do with a steel minier or by simply grabbing the wheel at the 3 o'clock and 9 o'clock position and moving it slightly. Now, when we're moving it around, you can move it around in multiple different areas and the wheel bearing will clunk. If you can only move it up and down in the 12 o'clock and 6 o'clock position, that's usually going to be ball joints. If you are, directly across, that's going to be tie rods. But if you can move it in a variety of different locations, that's usually an indication that the wheel bearings have gone. And so the mechanic here is giving a visualization of what that might look like. But you can also diagnose wheel bearings in a couple other ways. Usually driving the vehicle is going to be a big one. Now, often if we have a live axle vehicle, these wheel bearings can transfer their noise up into different components. We also, too, might have a difficult time trying to delineate the noise, and quite often we're going to have to move the vehicle to one side or the other. Based off of if the issue is with the bearing loaded or unloaded is how we're going to determine whether or not it's making the noise. So if we have a right front bearing making noise, if we turn the vehicle to the left, that can load the bearing up. And if the bearing is making noise only on coast, with the bearing loaded, it will quiet up. Versus if we were to turn to the right, the bearing would become unloaded and thus make noise. But again, that's going to be based off of whether or not the bearing is making noise unloaded or loaded. And again, you're going to be driving the vehicle from left to right. And then you can monitor the frequencies or the noise with chassis ears. Chassis ears are little microphones that you can place on the vehicle in multiple different spots to diagnose that. Now that kind of goes through bearings, gaskets, and seals a little bit quickly. We will be looking at those in greater detail in every single chapter that we're covering, and we will look at in greater detail in diagnosing our bearings when we come to different the transmission subsystems. But do keep in mind these are very important systems for modern automobile to function, and we do need them, and they are required. So I appreciate you sticking to the end of the lecture, and I will look forward to seeing you in the next one. Thank you.